The Circle of Willis is a challenging area to scan in MRI. The arteries form a complex network at the brain's base, with vessels that are both small and delicate. To get clear images, we must separate flowing arterial blood from the static brain tissue around it. The 3D time of flight, or TOF sequence, solves this problem by saturating static tissue, while fresh, inflowing arterial blood appears as bright signal. This gives us clear MRI images of the Circle of Willis without contrast injection. Let's start planning this sequence. First, we must ensure enough spatial resolution to capture the fine details of these arterial vessels. We can set a standard spatial resolution with our field of view, matrix, and slice thickness parameters. We'll also add enough slices to cover the Circle of Willis and surrounding vessels. Our coverage should extend from 1 centimeter above the corpus callosum down to the foramen magnum. Next, we'll angle our slices to run parallel to the splenium and genu of the corpus callosum, these 2 points shown over here. We can also add a superior saturation band, which will suppress venous flow and make the arterial blood stand out clearly. Now let's fine-tune our parameters to darken background tissue while enhancing arterial blood. We start with a short repetition time, typically 20 to 40 milliseconds, which saturates the stationary tissue. To reinforce this effect, we set our flip angle between 20 and 30 degrees. Next, we set our bandwidth per pixel between 100 and 200 Hz. This avoids chemical shift and allows the shortest possible echo time. Our echo time should be as brief as our hardware allows, because this prevents T2 star decay and makes flowing blood super bright. Finally, we can add fat saturation, which will eliminate signal from fat and boost our background suppression even more. Let's now run this sequence. Excellent. Here we can see how our acquisition suppressed the background tissue very well while keeping the arterial blood bright. This non-contrast acquisition helps us detect conditions like aneurysms, stenosis, blockages, and arterial thrombosis and malformations, and it's extremely valuable for exploring the brain's arterial system.